I hope I get really lucky. I would try to read them, but then I would look at the question and I'd be like, okay, which one makes more sense? Oh, yeah. I did try. Like, I was like, I was like, I can block it. Because I could tell I was zoning out and not I was like, this is important.
Jennifer, are you hiding back there? Thank you. Mitzi, good.
Yeah, where were you first out?
I love this.
All right. Okay. So, ladies and gentlemen, tomorrow you are going to need your goggles. Now, if you left me your goggles at the end of the first trimester, I have them for you. Matter of fact, I will put the box up in the front here along with the second hour box. You can find your goggles if they're in there, and you can put them in the second hour box. If you don't find them in there, you did not leave them with me. Okay? So we will go through and we will do that today so that you know if your goggles are here, because you have to have your goggles for the lab tomorrow because you're working with concentrated acid. And then on Friday, you have a quiz, ladies and gentlemen. Cynthia, just for you, I have written on the board what the topics for the quiz are. The rest of you can feel free to look at it as well, too. But molar conversions, going from volume to mole to mass, mass to mole to particles to atoms, and determining an empirical formula. So there's only 2 problems on your test, on your quiz on Friday. Questions?
So are we taking the test next week?
This Friday.
Wednesday? No, this Friday.
No, we're taking a test next week, Friday.
No, next week Wednesday.
No, that makes no sense, because then what would we do?
It's not fair.
Well, it's not my fault you're not going to be here.
Yes, it is.
And what you do does not affect my plans. And yes, I just said doo-doo in
It's
class.
not only me, it's like more people from your class are not going to be here.
It's
How
like
many people are not going to be here next Friday? Okay, good news. On Monday when you come back, it will be waiting for you. Okay? So I am not crazy because the psychiatrist said I wasn't. So
Yeah, it's okay.
You're also paying her.
it's a free consult.
Just from those
Okay, do you have any questions about empirical formulas from the other day, ladies and gentlemen?
Yeah, can you do them?
I can do them, yes. I have no problem. I've been doing them for 27 years.
In front of us.
Like, teach the whole class all over again.
No, I'm not going to do that.
Why?
Why? Because I want to give you time to actually work on them and do them. When you watch me do them, that doesn't help you. Okay? So, okay, here's how you find an empirical formula. If you are given percentages, the easiest thing to do is to assume a 100-gram sample, because your percentages become grams. My turn for a little while. You'll have plenty of time in just a few minutes. So, you convert your percentage sign to a grams because you're going to assume a 100-gram sample. So 38.13% of 100 grams is 38.13 grams. You can assume whatever sample size you want. The easiest to assume is 100 grams. That takes all of your percentages and gets them into grams. After you've gotten your percentages into grams, ladies and gentlemen, you are going to take and convert them into moles. We use formula mass, which is easy because it is one element on the periodic table. The formula mass is the number for manganese, magnesium, iron, carbon, whatever the element is. You will then get it into moles. For every one that you have into moles, you will then find the smallest number of moles out of all of your conversions. In this case, out of these 3, the smallest number is 0.694. I divide them all by 0.694 because it guarantees me of getting a ratio where there is 1 of something. Now, sometimes it is not a 1 to something ratio. Sometimes it is a 2 to 3, in which case you will end up with one of these having a 0.5 at the end. If you get a 0.5, you are going to have to multiply all of them by 2 to get rid of that 0.5. If you get a 0.33, you are going to have to multiply all of them by 3. If you get a 0.25, you're going to have to multiply all of them by 4. Everything else will come out close. Doesn't mean it's going to be exact, but maybe it's 1.97. That's close enough to round to 2. Maybe it's 2.1. That's close enough to round down to 2. What we can't round is when we get a quarter, a third, or a half. Then we have to take care of those in another way, as I showed you. Here. So again, oops, sorry, getting in the way. When we get something with a 0.5 in it, we multiply all of the coefficients times 2. Okay? Now, this compound has to have a what in it because there are 3 elements? I don't see parentheses there. It has to have a polyatomic in it. So if you have a formula that has a polyatomic in it, you need to flip your periodic table over, look at the backside, and try to find that polyatomic. And then name it. Okay? And then name it. So Cr2O7 is dichromate. Okay? So that is what you name it. All right? In today's practice problems, you may find ones where it is N3O9. Find me the polyatomic N3O9 on the back of your periodic table.
Can't you simplify it?
No, you can't. This is 1, 3, and 9. Yeah.
Well, it's nitrate. You just
What? What's the formula for nitrate?
NO3, but you multiply the whole thing by 3.
Correct. Point being, ladies and gentlemen, when you get an empirical formula, it will give you a ratio that looks something like this. You will not find N3O9 on the back of your periodic table. You will, however, find NO3. And if it's 3 and 9, that means there had to be 3 of these groups here.
Why don't they just give it to us like that?
Because they can't. It's only giving you the ratio of the elements involved. So when you get that ratio, you will get something like this. Now you need to figure out what this polyatomic is. Okay? So again, the polyatomic, you were correct, Sophia, when you said, well, why don't we reduce it to NO3? We can, but then what that means is what you reduced it by is going to go outside of the parentheses. Okay? Outside of the parentheses. You'll find one like that when you're practicing today.
So basically the ratio of NA is 1, the ratio of 1.
If we get it down to lowest terms in this problem, the ratio is 1 to 1 to 3.5. The problem is it can't be 1 to 1 to 3.5. It has to be a small whole number ratio. But when we divide by the smallest amount of moles, it's going to guarantee us of getting a 1 somewhere in here. In this case, here and here. It will always get you a 1 though. And now when you realize this number is 3.5, now we need to double everything because it wasn't 1 to 1 to 3.5. It was 2 to 2 to 7 as a whole number. But again, this doesn't have to come out as a whole number always. The only one that does is the one where we get 1. So you might get a number like 3.33. Well, if that's the case, we multiply everything by 3 to get rid of that 0.33. I'm not going to give you ones that are difficult, though. They're either going to end with 0.5, 0.33, or 0.25. Okay? Questions? Okay.
That part is on Google Classroom, right? The little red box.
Yeah, this is the notes that are in the master notes that I have in the Google Classroom site. Okay. At the lab stations in the back and at the two tables in the middle, ladies and gentlemen, there are 4 practice problems for you to do. Get a partner, get to a station, chalk markers are on the back in the middle. Grab a magic eraser, which is a wet towel out of the bucket, go to a station and start doing the problems. And then if you need answer keys, ladies and gentlemen, you can go up and borrow one off of the gray card in the back. Check your work or call me over and I will check it for you. And then you can move on to the next one. Let's go. Oh, by the way, don't forget, if you left me goggles, these are the goggles that were left here last trimester. Make sure you get them in this box so that they're there for you tomorrow. If they're not in that box when you come to class tomorrow, I will rent you a pair for 50 cents. So all I'm asking is if you find yours to put them into the box. Your ET, they're in the box. I think that's yours. Okay, they're in the box. OMTZ. No clue. What's that? She's in this class now, right? Arhan. I know. No, you don't hit. Okay, then maybe put an initial. What color? You're welcome. Anyone need an eraser? Eraser? Erasers? Erasers? You're good? You're good? Erasers? Number one, you're going to need a Roman numeral in that name. If you're going to name that compound with iron and oxygen, it has to be a Roman numeral in it. No. What is the chunk? Oh, I hear it. Okay. The good news is what you're doing is that then sulfur, then oxygen. Find me S. Three and so this process. If you it doesn't know this is the only entry, it doesn't know that it's sulfur. Yeah, because of their problem. I didn't ask you today. Only 12. There might be four. If there's only two elements, it's something that we can name based on the non-metal. If there's three or more elements, unless they're all non-metal. If they're all non-metal, then you just them in the order. You're not going to be able to name them. They'll never get it. Right, but it's also good. So because the aluminum is gold cheap. There's sulfur and oxygen in there. Well, it has to be SO4. PSO3. Right. SO3. And it could be sulfite. So don't just assume because there's only one compound that's sulfur and oxygen in the bag. It has to be SO4. So therefore, but again, we've got our numbers. That's 3 over 12. If that into SO4, it is. Formula is going to be UL2, that's 4, and 3. I will never grade your acidics in the middle of the product. So thereby, this number has 3 significants. So, okay, they decided they're going to carry 3 significants. This number has 4. This number has 4. I'm going to bring you up safe things at the very end of the process. When you're determining the formula, there are no safe things involved in your numbers. Okay? But, don't make them round answer. So if you round this to 0.5, and you round this to 0.2, you're not right. All of them is 0.2. 0.5 divided by 0.2 with a hit. So don't move that. Why you get to this? No, the only thing that's wrong is the top one, and all you need to do is change this. But you need to change the number.
Yeah, I don't. You are so behind, like, no, because 2 months ago.
Great. Well, here's the thing. Get rid of it. Here's- it's- Yes. Okay. What color, Cynthia?
What colors do you have?
Red, blue, green, black. What? I don't think that's going to show up very well, but there you go. Sophia, what can I do for you?
I will figure out the
Other than the fact that it's
wait, we have one.
Somebody that doesn't formula for that? C28302. Why? It gets reduced. The problem is, when you're dealing with it, if it's just a metal and a non-metal, we know how those charges are. But when you're talking about a polyatomic, is it carbonate? Is it oxalate? Is it carbonite? Is it hypocarbonite? Is it percarbonate? There are a lot of different formulas that involve carbon and oxygen. And the only way we can figure it out is to actually try well, you can just carbon and oxygen. It's going to be a polyatomic. You put some metal with the carbon and oxygen, then it becomes one of these polyatomic carbonate, oxalate. If it's just carbon and oxygen, it could be carbon monoxide, it could be carbon dioxide. So you can still have but those are the only two elements in there. The reason it's polyatomic is like green ball is
Right there. As you like learn the silver, so maybe we'll get to that. Bring our mistakes because I do. And I was no, does this matter?
Yes, but I haven't given you one like that yet, so I will show you how to do that. It doesn't matter what you done here. Do that. Do that for the last step. So that will obviously not be like this. I'll show you how to do it like still, we're good.
Watch Facebook steps. This quiz. It's only 2 questions. Watch
And
this.
don't get messed up. Take what you're given, get it into moles. Divide by the smallest one. That is how we find any empirical formula. Any empirical formula. That's what we do. Okay? Now, here's the other thing you're seeing. On your periodic table, somewhere, make sure you have these. When you were going to volume, you were putting your numbers. Don't do that. Okay? If it's mass, it's formula. If it's volume, it's always 22.4. If it's particles, it's always 6.2. Okay?
I don't like watching it.
Somebody's sitting in the periodic table back there that has an awful lot of notes on it. By the way, if you're doing this and you come across markers that don't work, please throw them out for me. We'll put them back in the container because that doesn't do me any good. What? It was, but now it's going to be a multi-step. Going from volume to gram, going from atoms to mass, going from atoms to volume.
That's a long time ago. Yeah. And I was like, oh, that's weird. Like, we would not be doing that. And she got back to the final race. I was like, oh, I just like I knew I was. I just don't care. It's the best way. I think all the time. What's better than my here? I know. Yeah, literally. Yeah, you should see. I know. Imagine the photos. Imagine the That's crazy. I'll go on vacation and you can rent out my house. But I'm sure that
Hey, please listen. Tomorrow, ladies and gentlemen, you have got your lab. Your lab requires you to have goggles if you didn't check in the box, and if you don't have them, you're renting a pair of mine for 50 cents tomorrow. Well, it's called law of supply and demand. I have the supply, so I get to demand the price. I took care of them because you didn't earlier. This is 4th hour stuff. 2nd hour box is already back there with your goggles in it because you didn't do it when I asked you to.
Yep.